Hello, let's solve quadratic applications using tables of value and scatter plot. Here's a problem for us. Perimeter of a rectangle is 20 centimeter. What dimensions in the set of natural numbers of this rectangle will give maximum area? So we can use many methods, but to start with, we'll use table of values. So first thing here is we are given a problem. Let's try to make a diagram which represents the problem. Okay, so we say perimeter of a rectangle is 20 centimeters. So let's draw a rectangle. What dimensions? Let the dimensions be W and L. Okay. In the set of natural numbers, you know what natural numbers are? 1, 2, 3, 4. 0 not included. Of this rectangle will give maximum area. So you know what is area? Area is width times length. And what is perimeter? Twice width plus length. So we know all this. So let's have equations. And because there are two variables, we should expect two equations. Correct? So first one, perimeter. So let's say perimeter P is equals to 2 times length plus width. Correct? How much is the perimeter given to us? 20 centimeter. So let's write 20 equals to 2 times length plus width. Now we can simplify it, dividing by 2 on both sides. So we get 10 equals to length plus width. Now from here we can write one variable in terms of the other. Correct? So let's write W in terms of W. Okay, let's say length is equal to 10 minus W. Okay. Now, so when we have this length equals to 10 minus W, then we can use only one variable and get the area. Now for this equation, what is the area for this rectangle? You know, area can be written as length times width. Now from the above equation, let's call it equation 1, we can substitute this value of L in our second equation. Let's say this is 2, and then get one equation in just one variable for area. Because why did we find area? Because the question says give maximum area, dimensions that will give maximum area. So we got area. So we can write this as length is 10 minus W times this W. Now you see this is in one variable, W. So we can write it as a function of W. So now we have area as a function of W. Correct? Now from this equation we can have different values of W and find area. And now from the table of values we can try to find what the maximum area is. So we can now replace this side. Now what we have got here is, let's make table of values and do. So here I already have a table and we will use our equation. So what is our equation? AW equals to 10 minus W times W. Correct? Now we'll take some values of W and find the area. Let's say this column we take W, and in this column we write area, which is equal to 10 minus W times W. Correct? Okay. So we can take width as 1. If we take width as 1, then 10 minus W is 9. Correct? Times W is 1. What area do we get? 9 times 1? 9. Correct? Similarly, if we take W as 2, we'll get 10 minus 2 as 8. And W is 2. So we get an area of 16, right? If we take 3, then it is 7 times 3, which gives us 21. Likewise, we'll continue. 8 will give us 10 minus 4 as 6 times 4, which is 24. 5 will give us 10 minus 5 as 5 times 5, which is equals to 25. 6, 10 minus 6 is 4, times 6, value is 24. 7, 10 minus 7 is 3, times 7 width, we get 21. 8, and then we have 10 minus 8 is 2, times 8, we get 16. 9, 10 minus 9 is 1, times 9 equals to 9. 10, 10 minus 10 is 0, times 10 we get 0. Well, 0 should not be included because it is not a natural number, correct? You can see if I take 11, there will be a negative number. So width and length can never be negative, correct? So in our domain, we can only have values from 1 to 9, not 10, correct? Now if you see this, then you will find where is the maximum? The maximum is right here. So area for different natural numbers of width is 9, 16, 21, 24, 25, and then 24, 21, 16, 9, right? And this value we should not consider, correct? Why? Because 0 is not a natural number, correct? So using table of values, we can find the dimensions of our rectangle. So basically what do we get? Width is how much? 5. And length is also 5, correct? Units are centimeter for dimensions and centimeter square for area. So we can write here in centimeter and in centimeter square. Does it make sense? Correct. Now here what we can do is we can just plot these values and get a scatter plot. Okay, so here we have a graph. Let's say this is 5, this is 10, let me write. Then this is 20, and it's 25, and this is 30, correct? This side, let's have area as a function of W. And this side we can have width, right, in centimeter, and W in centimeter square, correct? Let's plot our points. At 1, it is 9. So at 1, 9 will be like slightly here, okay? 9. At 2, it is 16. So for 2, 16. So it is like 10, 15, and it's 16. At 3, 21. So 1, 2, 3, and 20, and more than 1, 21. At 4, 24. So 1, 2, 3, 4. Let me write 4 here. 24. So this is 20. And this is 25, so below 24. And at 5, we have 25. So this is our 5 at 25, correct? And 6, it is 24. So that is 6 and 24. 7 is 21. 21 is here. You see they are symmetric, correct? At 8, it is 16. So we get 8 and 16. And at 9, we get 9, which is slightly below 10, correct? So this scatter plot which we have is kind of a parabola, correct? And where is our maximum value? Here it is. Do you see that? That's the maximum. And the maximum is at width of W. We get maximum area, which is 25. Do you get it? So we can solve this problem in many different ways. One, scatter plot, like we have seen here. Second, table of values, correct? Now from here, can you tell me why did I not join these lines? Think about it. Why did I not join the lines? Because what is our domain? Our domain here is set of natural numbers, and these natural numbers are 1, 2, 3, 4, 5, 6, 7, 8, and 9. How about range? Range is a set of numbers for area, and those numbers are 9, 16, 21, 24, 25, and the others are repeated. So only these, correct? So that's our domain and this is our range. Why are we not joining it? Because it is not set of real numbers. You should join these points if we are working in the domain of real numbers, not when we are working in the set of natural numbers. So what is our answer now? We see that for width of 5 centimeter, we have maximum area of 25 centimeters square. Now what are the dimensions? Did you remember what is L in terms of W? Yes, we found that length is equal to 10 minus W, and because W is 5, length will be 10 minus 5, which is equal to 5. Therefore, dimensions of rectangle are 5 centimeter by 5 centimeter. So that's how we are going to do it, correct? Do you get it? So if you are given a problem, like in this case, let me go through it again, review it for you. So we started with the problem of finding perimeter, or of finding the maximum area dimensions which could give maximum area of a rectangle given perimeter. So from perimeter, we know perimeter is twice length plus width. We found a relation between length and width. So we wrote length as 10 minus W. We could have written width as 10 minus L, right? And got an area in terms of length also. That was also correct. Well, we chose to do this. And so when we did this, then we got relation which says in our rectangle, if W is the width, then length is equal to 10 minus W, correct? Now based on that, we found the area for different values of width. And this is the set of values which we got by placing width as 1 to 9. So as we went beyond 9, we saw that the length was, or the dimension of length was 0. So that is why we could not continue further. So our domain is restricted to numbers 1 to 9. And the range was the calculated values. And the range calculated was 9, 16, 21, 24 and 25. Maximum value from our table was 25. So that is the maximum area. And how did we get it? With width of W and 10 minus W is our length, right? The first bracket value, 5 length. So the dimensions are 5 width, 5 length, and the maximum area is 25 centimeters square. So that's how we, in word problems, you should definitely write down a word statement giving the answer very clearly. As we have mentioned here, the dimensions of rectangle are 5 centimeter by centimeter. Thank you.